Today we're going to be talking about converting between radical form and rational exponent form. Radical, we know, is going to have the square root or the radical symbol, not necessarily a square, but a radical symbol, and a rational is a ratio. So let's go ahead and talk about this. We'll call that inside exponent P. So when we write it as a rational, the P will be in the numerator. The index, we'll call it R, and the index will be in the denominator. That's the index of the roots, how many sets we need in order to come outside the radical. So go ahead and write that down in your notes, and let's move on. I want you to kind of think about this as a tree. A tree roots go on the bottom, so the root will always go on the bottom. If that helps you in how to decide where to put the inside power and the outside power, hopefully that'll help. All right, so here's some examples. We're going to go from radical to rational and rational to radical. Let's get started. So we have the square root of x. First, we know the inside power is 1. There's nothing on the outside, so we know it's a 2. So if we had to write this as a rational exponent, that means no radical. It is x raised to the 1/2 power. That's radical to rational. Let's take a look at the next one. On the inside, y is to the first power. On the outside, which is the index, it is the third root. The root goes on the bottom. Sometimes I like to write the root first so that I know any other powers are going to go on the top. There we are. So this is radical to rational. All right, let's flip it around, and we're going to go from rational exponent and put it back into a radical. So the first one on the bottom is a 3, so we put that on the index. This is the cubed root of x. The next one, the 5 is the root. It is the index. This is the 5th root of m. Our next one, the root, which is on the bottom, the 6th root of b. B can't come out unless we have a set of 6. Y to the 2/5 power, written as a radical, is the 5th root of y squared. Alrighty. So that was level 1. Let's take it up a notch to level 2. Radical to rational. Take a look at the cube root of 5a. 5a is inside the radical, so I went ahead and put that inside parentheses. It is all to the first power, so that's what's in my numerator, and the root is at the bottom. It is 3. Let's take a look at this next one. Ay, all raised to the 1/3 power. Well, we don't have a radical, so we're going to turn it into a radical. And so the 3, which is on the bottom, is going to be the index, and I put it in place. The cube root of a times y. Take a look at this one. This one could be tricky. We have x squared minus y in parentheses. So we brought it out and put it in parentheses. It is all to the first power. What is the power outside the parentheses? Some of you want to look at that too, but no. Put it in parentheses, and it is the cube root, so that goes on the bottom. Take a look at the next one. This one could be tricky. All right, I want you to notice that 2a cubed raised to the 2/5 power. Let's start with the 5. That's the 5th root. We'll write our radical, and we'll write the 5 in there for the 5th root. Now inside we write 2a to the 3rd power, all raised to the 2nd power. Now because we're just practicing this right now, I'm just trying to show you where everything goes. However, when we have problems like this, we definitely will simplify that some more. The next one, we take everything on the inside and put it in parentheses. 3 times x times y to the 4th. As soon as we put it in parentheses, we can see it's to the 1st power, and it's the 5th root. So it's 3x y to the 4th raised to the 1/5 power. Take a look at this last one, pause the video, and see what you can do on your own. Hopefully this is what you got. All right, so let's simplify with rational exponents. If we're simplifying with rational exponents, should we have a radical in our problem at the end? And the answer is absolutely not. We're going to start off by writing it with rational exponents. The root is 3, so we put that in the denominator. This is m to the 9 over 3. Are we able to leave it like that? Absolutely not. This is m to the 3rd power. And basically on the outside, how many sets of m's will come out? It is m to the 3rd power. Let's take a look at this one. If you can rewrite in exponential form, by all means, you should do it. A base to a power. First, how many zeros do we have here? 8 of them. So let's write this as 10 to the 8th power. And then it's the 8th root. So we simplified it as a radical, and now we're going to write it as a rational. This is 10 raised to the 8 over 8 power, which is 10. Anytime you can rewrite in exponential form, do it. Simplifying with rational exponents. 125 to the 1/3 power. If you can rewrite in exponential form, do it. I rewrite 125 as 5 to the 3rd power, all raised to the 1/3 power. Now, when we have power to a power, we definitely multiply. So this is going to be 5 raised to the 3 over 3 power, which is 5. 3 over 3 is 1, 5 to the 1st power. I'd like for you to probably get a calculator so that you can put in a calculator 125 raised to the 1/3 power so that you can see that, yes, you would get 5. So what's the rule? If you can rewrite it in exponential form, do it. It just makes it that much easier. Let's take a look at this last one. I rewrote 16 as 2 to the 4th power, g to the 4th, h squared, all raised to the 1/2 power. Now this is power to a power, so I'm going to multiply every power on the inside times the power on the outside. So 2 to the 4th times 1/2 is 2 squared. G to the 4th times 1/2 is g squared. H squared times 1/2 is h. Can I leave it like that? No. If you have numbers that you can multiply out and simplify at the end, you must do it. Final answer, 4g squared h. Let's try these. Rewrite 81, 3 to the 4th, m to the 6th, all to the 1/2. This is power to a power. Multiply the exponents on the inside times the exponents on the outside. 3 squared, m cubed. 9m cubed. All right, next, 64. How would we rewrite 64? 2 to the 6th power, n to the 12th, all raised to the 1/6 power. When I do power to a power and I multiply 6 times 1/6, I get 1. 12 times 1/6, I get 2. Final answer, 2n squared. Whoa, what is this? Simplifying with rational exponents. This is a radical within a radical. So I see the square root of 7, and whatever that answer is, I'm taking the cube root of that answer. Let's see. Let's just go ahead and put in our values here. It helps sometimes. So on our inside, we have 7 to the 1/2 power because the exponent on the inside is 1. There's no index, and so we know it's 2. So we rewrite the inside as 7 to the 1/2 power. Now we need to take the cube root of that. So when we take the cube root of that and we put it in parentheses, we have 7 to the 1/2 power raised to the 1st power, and it's the cube root of that. So what we can do is Take a look. So this is 7 to the 1/2 power, which is on the inside. The root is the cube root, so that goes in the denominator. And then we have 1 at the top. We get back to power to a power. So we multiply 1/2 times 1/3, and we get 1/6. And that is how we simplify with rational exponents.